Hello, everyone. Welcome to my poster session. I'm Jimmy. I'm a PhD candidate from Columbia Business School. Today, I'm happy to present a project modeling patient no-show behavior in outpatient clinics, in-person versus telehealth. This is a joint work with Professor Carrie Chen and Professor Jing Dong, both from Columbia Business School. In this project, we aim to develop evidence-based approaches for the management and integration of telemedicine and in-person visits. And in particular, we want to take an empirical approach to understand determinants of the patient's no-show rate and study the implication in scheduling and sequencing decisions. Why do we want to study no-show? This is because no-show can lead to inefficient use of staff time and other resources. And no-show is an important factor to take into consideration when designing and optimizing an outpatient appointment scheduling system. We have the appointment scheduling data from our industry collaborator. We have very detailed patient level and patient visit level information. We also have various timestamps, including schedule time, actual check-in time, and actual check-out time. As a preliminary study, we first show that the no-show probability of a particular in-person patient is only affected by the no-show rate of other in-person visits, but not affected by the no-show rates of other telemedicine visits. On the other hand, the no-show probability of a particular telemedicine patient is only affected by the no-show rate of other telemedicine visits, but not affected by the no-show rates of other in-person visits. In other words, there's correlation within the same modality, but not across modalities. In order to explain this phenomenon, we propose that there are some factors only affecting one modality of visits, but not the other. Specifically, we first show that bad weather is only affecting in-person visits. As you can imagine, suppose during a particular time of the day, the weather is really bad, then probably a group of in-person patients will not show up, and the bad weather will not affect the telemedicine patients. And that is where the correlation within the modality comes from. Secondly, we show that telemedicine patients are very sensitive to delays, meaning that if the doctor is not available at the beginning of the scheduled time, then telemedicine patients are very likely to leave the system early without being seen. In order to estimate those effects, we have several estimation challenges, and I just list two of them here. First, data not missing at random, and second, the endogeneity issue. Both of the challenges may lead to a biased estimation, and we come up with some econometric strategies to deal with those issues. As next steps, we will study the implications of these observations on the scheduling and sequencing decision. Thanks for listening, and I'd love to hear any comments and feedback from you.